Today, we will see Mars not as a red point in the sky, and not only as still photographs sent back to Earth, but as a landscapes brought into motion from real images captured by NASA's rovers, not as a fantasy, not as a dream, but as a visual journey across real Martian terrain. Mars moves around the Sun at a speed of 24 kilometers per second. Earth moves at 30. Mars is farther from the Sun and it travels more slowly. A day here lasts 24 hours and 39 minutes, almost like ours. Gravity here is 38% of Earth's. A 20-kilogram object would weigh only 7 kilograms for you. Your own body would feel more than twice as light. But the strangest part begins not when you lift things, but when you move yourself. On Earth, a jump from 1 meter already puts strain on your knees. On Mars, you would feel the same load only if you jumped from 3 meters. Every step becomes almost a leap. Mars makes you lighter, but it does not make you invulnerable. 10 Martian years are almost 19 Earth years. Time on Mars is measured differently. Not faster, not slower, just differently. At the height of Martian summer near the equator, daytime temperatures can rise to positive 20 degrees Celsius. By Earth standards, that number sounds almost comfortable, but this is not the temperature of an Earth summer day. On Mars, this is how the surface itself can warm: the ground and stone under direct sunlight. The air around a human being remains cold. Near the surface, that number may still seem almost Earth-like. But already at head height, the temperature can be close to freezing. And when the sun sets, the illusion disappears completely. At night, the temperature can plunge to minus 70 degrees Celsius or lower. The Martian atmosphere is so thin that the surface quickly loses heat, radiating it back into space. On Mars, warmth is not a condition. It is a brief pause inside the cold. But Mars does have seasons: spring, summer, autumn, winter, almost like Earth. Only Martian year is almost twice as long as an Earth year. So one season here lasts on average about 6 Earth months. And all of this is happening on average 225 million kilometers from us. But we cannot go to Mars whenever we want. The launch opportunity lasts only a few weeks and comes roughly once every 26 months, when Earth and Mars are in the right position relative to each other. And in 2026, November 7th falls inside that opportunity. From there, the spacecraft follows a long arc around the Sun, not toward where Mars is now, toward where Mars will be months later. In this transfer, the journey would take about 265 days, almost 9 months between two moving worlds. But landing on Mars does not mean the journey is over. On the most fuel-efficient return path, astronauts could be forced to stay here for roughly 500 days before the next return window opens. For almost a year and a half, Mars would not be a place to visit. It would be a place to survive. For more journeys into the questions that still remain, subscribe to the Before We Arrive channel. Right now, at this very second, spacecrafts from several space agencies are operating around Mars. On the surface, 2 rovers are still working. They photograph, drill, measure, and send gigabytes of data back to Earth. According to measurements from the Curiosity rover, on the open surface of Mars, a person would receive about 0.67 millisieverts of radiation per day. On NASA's scale, that is roughly comparable to 6 or 7 chest X-rays. But there is one important difference. In a hospital, that is a brief scan of one part of the body. On Mars, it is an entire day in which the whole body receives the radiation dose. That is why the future of humans on Mars will probably not begin under the open sky, but under rock in caves, where the planet itself can become a shield. But there is another danger that can follow you through the airlock. It is already everywhere, under the wheels of rubbers, on the rocks, in every crack. Dust. But Martian dust is not harmless sand. The soil contains perchlorates, toxic salts that can be dangerous to humans. For future explorers, that would not be just dirt on a spacesuit. It would be contamination, something that could follow them inside the habitat, into the air, into the water, into the food. And that is only the first layer of its chemistry. Because this dust is not just toxic, it is also the reason Mars looks the way it does. It contains oxidized iron, rust, the same thing that forms on an old nail after years of rain, a red stain that appears after iron meets air and water. Only here, rust covers almost an entire planet. When the wind rises, this dust becomes part of the air, not a cloud in the way we know clouds on Earth. More like a thin red veil, slowly erasing the boundary between sky and ground. During a major dust storm, Mars can almost lose its surface details from orbit and turn into a blurred yellow ochre disk. That is why Mars appears red, not simply because of the light, and not because the atmosphere itself is red, but because of iron in the rocks, the regolith, and the dust, all shaped by a long history of oxidation on its surface. Iron is in us too. In every drop of our blood there are billions of hemoglobin molecules. Inside them there is iron. That iron-bearing structure helps carry oxygen to every cell in our body. And it is also tied to the red color of blood. Planetary scientist Sarah Stewart Johnson wrote that in a NASA Ames laboratory where researchers worked with a Martian dust simulant, she suddenly tasted blood in her mouth. But it was not blood. It was the metallic taste of dust hanging in the air. Before we arrive on Mars, we already know one strange thing. Its dust may not smell like sand, not like a desert, not like a stone, but dry, metallic, rusty. On Earth, iron is inside us. It moves through our veins and helps carry life. On Mars, iron is outside. And somewhere here between chemistry and sensation, a thought appears that is hard to forget. Mars smells like blood.